let's have a look at how vSphere HA does its thing. We'll look at the heartbeat mechanisms that are used by HA, and we'll discuss some of the failure scenarios. And then, as we've learned about the architecture, that will lead us to proper design of our vSphere HA infrastructure. So let's go ahead and dive right in. Now, when you take an ESXi host and you move it into a cluster, you just drag and drop it into the cluster and you enable HA, there's a process that starts on ESXi, and that's called the Fault Domain Manager, or FDM. And that acts as an agent that allows for communication of heartbeats between each of the ESXi hosts. Now, what happens when you add the first host to a cluster is a timer starts, and that timer runs for 30 seconds. During that 30 seconds, it's waiting for other hosts to join the cluster. If another host joins the cluster, the 30-second timer is restarted. Finally, the 30-second timer will elapse after no hosts have joined the cluster. And at that point, there's an election process that happens. There's communication between all of the hosts that have joined that cluster that have HA, the cluster that has the HA enabled, and an election happens. And we elect what we call a master host. And this master host is the host that's in charge of the entire cluster operation. What the master will do is collect a list of all the hosts, a list of all of the VMs that are running on that host, and it'll actually save that as a file in the FDM directory in your ESXi host installation location. It'll then copy that file to each of the other ESXi hosts so that each host has the capability of actually becoming a master. Okay? The master is the only one that actually ever does anything other than respond to a heartbeat. The master will send heartbeats to each of the ESXi hosts. It'll listen for the response to that heartbeat. If it doesn't receive a heartbeat, it will check the data stores that the hosts are connected to for something called a data store heartbeat file. That data store heartbeat file that the hosts have a lock on will ensure that the ESXi host that is in question, the one that hasn't responded to the heartbeat, is not actually isolated, okay? And if the host has found that it's not isolated, the master host has found that it's not isolated but actually down, the master will then restart that the down host's VMs on other hosts, okay? So we have master hosts and subordinate hosts. Now, who actually becomes the master host? How do we know who has won the election? Well, it will happen to be the host that has the access to the most data stores, okay? The host with the access to the most data stores becomes the master. If there's a tie, then it's typically the first host that's joined the cluster. So it's this master host that's sending the heartbeat over the management network, or in the case of vSAN, over the vSAN network. So it's important that we have redundancy in this so that if there is a failure on that management network, the master host will retry the heartbeat over the secondary port, okay, and listen to make sure that that host is alive or not. Now, if there's no response over either the primary or the secondary management network, we check that data store heartbeat. It's a file that's stored in a folder on your data stores called .vSphere.ha. It happens to be a hidden folder. Okay? And each ESXi host will maintain a lock on that file, and it'll periodically timestamp that file. Now, if the master has not heard a response over the management networks for that heartbeat, the master will check the data store heartbeat region to ensure that the host is either alive, the host has a lock on the file, in which case we have an isolated management network, or the host is dead. There's no lock on the file, then the master host can say, aha, I need to restart those virtual machines. So what happens then with all of this heartbeat mechanisms that occur in the event of a subordinate host failure, or a master host failure, or a network isolation? And what happens in an all paths down or a permanent device loss scenario? Well, if we have a failed subordinate host, we know that the master host has attempted heartbeats on both primary and secondary management networks, and it's also checked that heartbeat region and found that the host in question does not have a lock on the particular data store heartbeat region. In that case, it's the job of vSphere HA and the master host to direct the restart of those virtual machines on hosts in the cluster that are alive. That is what we would typically understand the job of HA. When the master host fails, it's a little bit more complicated, because we know that nothing really happens other than responding to heartbeats without the master host directing it. So if the master host has failed, the subordinate hosts will not have received the heartbeat request from the master host. And the subordinate hosts will say, the master host must be dead. Okay, so what do? Well, we hold a new election for a new master host. And a new master host being elected will then attempt to become that master host and do all the stuff it's supposed to do. But the new master host has to verify that it actually is supposed to be the master. In other words, that we haven't had a network isolation. Because in the event of a network isolation, if the master host has become isolated and it's not able to send the heartbeats and they're not able to be received, then the master host is actually still alive. And the subordinate hosts will all elect themselves to be the master. Now we've got a whole cluster of master hosts, and that doesn't work for us. So here's what we do. When a host is elected or elects itself to be the master host, the first thing that we'll do is verify that it is not isolated on the network. It will check what we call the isolation address, which by default is our default gateway. So this newly elected master host will ping the default gateway. And you can actually set up additional IP addresses to be isolation addresses as well. Okay? So it pings the default gateway, and in the event that the master actually has failed and the network is not isolated, then it will receive a response, a ping response from the default gateway. It will know that it's supposed to be the master, and it will restart the appropriate virtual machines. If, on the other hand, all of the hosts have become isolated and they all elect themselves to be masters because there's no communication during the election period, okay, then what happens is the ping on the isolation address will fail. All of the hosts will declare themselves to be isolated, and they will then all enter the isolation response, which is configurable, and like I said before, the default is to do nothing, presuming that the virtual machine port groups and the virtual machine networks are still active and available. Now, if a storage network should fail because of a network misconfiguration or a failed network a switch or a power outage on the networking segments and things like that, okay, then we know that we've got to do something, okay? And we have this idea of permanent device loss, or all paths down. In that case, virtual machine component protection will either restart virtual machines on the same hosts if the storage network comes back within the first 150 seconds, or it'll restart virtual machines on other hosts if the management network or if the storage network takes longer than that to come back, okay? So it detects and responds to failures. Like I said, this is not enabled by default, but if you'd like to, you can enable virtual machine component protection in the settings, in the vSphere HA settings under, under host failure responses or under failure responses. Okay. Note here that this is not compatible with vSAN at all. Okay. The vSAN network should fail. It'll simply switch over to the secondary vSAN network. It also happens to be the same network that our heartbeats are occurring over. So there are a number of design considerations, and they all float around ensuring that there are no single points of failure so that we don't have false positives for host failures. Okay, so we're implementing redundant heartbeat networks. We want to physically separate our management network from our virtual machine networks so that even in the instance or the case of a management network isolation, the virtual machines can continue to run. And we also want to make sure that we separate management from IP-based storage or from any storage networks. Now, if you're using, of course, fiber channel, that's by definition a separate network. But if you're using IP storage, try to physically separate that as well from your management. Use a different physical NIC connected to different physical switches in your environment so that you're avoiding single points of failure, and that you, if you have a host isolation, you don't necessarily lose your storage as well. All very important design considerations around building your vSphere HA infrastructure. So that does it when it comes to the infrastructure and the architecture of our vSphere HA environment. And when we come back in lesson number 5, we're going to actually look at how all of this is configured. We'll talk to you very, very soon.